What's up guys, Shawnthebro here, and we're back for another episode of the fighting game tutorial series. And in today's episode, we're going to be continuing cleaning up our game. A lot of the recent episodes have been about going over cleaning up our game, converting blueprints to code, just consolidating logic, making them more efficient, and it's been going wonderfully. We've been doing all of this so that we can get into more advanced topics like rollback netcode and AI without having to do a lot of rework in the middle or rework at the end of it. And so our character, our camera, some of our hitboxes, our game mode are significantly cleaned up, and our AnimBP is in the process of being cleaned up. This is the thing I'm most excited about cleaning up, so I'm going to hit this pretty hard. Today's episode is a great one. It is about cleaning up our attacks, how we spawn our hitboxes from our animation blueprint. So I think the animation blueprint is the perfect spot to spawn hitboxes, or at least to trigger the spawn for hitboxes in our game, because the hitboxes are so animation dependent in fighting games. So in this case, when I am performing an attack and that collision occurs, that's because I spawned a hitbox that could damage them. And I have different types like throw boxes, or throw hitboxes, whatever you want to call them, and projectiles that can all deal damage to the opponent. Right now, all of our hitboxes are made the same way, but it's a pretty manual process every single time. We can definitely consolidate this and basically make every event do the same thing just by passing in a string. We will reduce a lot of the graph space due to this, which is great. Additionally, it actually opens us up to doing other things with it in the future so that we don't have to keep them so separated. Covering a few other cleanup things in our animation blueprint as well. Before we hop into that, if you want to get caught up in the entire series and check out how we've done things like our throws, our hitboxes, our projectiles, and a whole lot more, I'll link you to the top right corner right here, which is the entire fighting game tutorial series playlist. So you can check out all of that and a lot more. Alternatively, if you don't care about that and you only care about the animation blueprint, keeping one clean for your fighting game, we can absolutely cover that, and you don't have to follow the whole series to do this, but I do recommend that you watch some of the other animation blueprint episodes that we've cleaned up, because the topics in those AnimBP cleanup episodes are still relevant in today's episode, and I go over a lot of the reasons for why I think they're better, more efficient, easier to use and work with in the future and expand upon, and a whole lot more. So I'll link you to the first episode of the AnimBP cleanup right here in the top right corner. With that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series, but we're going to be cleaning up our animation blueprint, so almost all of our logic is going to take place in here today. If we go to blueprints, AnimBPs, and go to each of our character blueprints, specifically for me, I'm going to go to my mutant AnimBP root motion, because this is the character that has pretty much everything in it. And right here on the screen is a perfect example of what I was talking about. So we have these anim notifies, and they're everywhere. All of these are anim notifies of this type, or at least most of these are. And we have more for proximity right here, and more for ending our hitboxes or despawning them right here. So first things first, if we look at one of these events, this is for anim notify mutant heavy charge active. We can go and find the heavy charge animation in here. And this is our charge up attack for our mutant. So if we go to the heavy release, this is really where the damage is being done, and you can see the anim notify is right here. So this is when we're going to start being able to deal damage, because we're going to spawn a strike hitbox on this frame when the character is performing this animation. And the logic in here is consolidated from what we had initially in the series very early on, because we do have a data table where we can access these attacks or this hitbox data information, and then we're passing the information right in to create active hitbox. But we can actually convert all of these events to call the same event, just passing in one string or one name, which will then consolidate these two nodes into one. And while that doesn't seem like a lot, when we're going to keep doing this attack after attack, and we're going to do the same logic, we don't need to have this in separate places every single time. Now there are a few exceptions, like some of the stuff I was doing with 3D fighters. We can do the same thing for it, but I'm actually going to leave these ones alone since they have that 3D logic, and I'll show you what that would look like in the 3D fighter episodes. But you'll see we do this all over the place. The other huge advantage of doing what we're about to do isn't just because we can remove a node here and there. It means we can also do this sort of thing for our ended when we're destroying or despawning our hitboxes, and our started when we're creating our hitboxes. We can consolidate all of this logic as well while using the data table. You'll see right now we're still using just a random proximity hitbox. I haven't actually started using the ones from the data table. That's not how it should be. And honestly, the main reason I did this is because I just did not go through and design my hitboxes to properly use the hitbox data table. But why would I manually go in here and put in all this information if I could just make a function to do pretty much everything we need? So all these events that you see here, and here, and here, can be consolidated greatly. So we can go ahead and make a function to handle this. So if we go to our animation blueprints and we press plus function here, we can make a new one, and let's call this create hitbox from data. Create hitbox from data table row. And I want this to support any type of hitbox. Instead of separating it like we do now for the active, proximity, and throw hitboxes, and then having different events for these, I want every event to call this function that we just made, and we'll just pass it the corresponding row name, and it will know what function to call from there. Going into this function now, we need to give it the row name as an input. Now the row name of a data table is simply a name parameter. So if you drag off of this and type make, it will say make literal name. And so you can pass in a name here. It puts it in a nice enum format for you. So if you get rid of this node and go and select this one again, this was heavy attack hitbox 2. What you could do is make an array of all of these that are in the data table. You know the data table is not going to change at runtime, and then just access the specific one you want when calling this new function. And then this function will take care of the rest. So let's change this parameter that we added to be data table row name. We can make it the same type, just make it a name. You don't have to call it a literal name, a name will just work. And if we were to type in get data table row names, this returns an array of all of the row names for a data table. So we know that we're going to be in the mutant hitbox data. That's a guarantee if we're in our mutant AnimBP. Drag off of our out row names and we can make a variable off of this, promote this to a variable. Or you can simply go to variables plus to add a variable and then change it to type name with object type of array. So you see how this is 9 squares, 3 by 3. If you click on a variable, go to the details panel, you can click on the variable type here. Usually it starts as single, which looks like this pill, but you can change it to an array, set, or map. An array is good here, so we can change it to an array, and we have an array of names. And we'll call this hitbox names. If we get all the data table row names and just set an array to all of those initially, like in Blueprint Initialize Animation or even before that, then we can easily access the one we want based off of an index or an enum or whatever. And when you have a hitbox name, you can get a copy of the one at a given index to then pass it into our new function. So we have create hitbox from data table row, and we're taking the data table row name, we can just pass this name into it. So for now, we just need these 2 nodes. Let's go ahead and copy these and move them over to somewhere where we're starting out. Blueprint Initialize Animation works. We did clean this up recently. We have a little bit more to do in here, but for now, we can just put it at the very end of this logic. So we're going to get all the data table row names for our mutant hitbox data and set that to our array here. Now going back to our example, so we had mutant heavy charge active and we were getting the data table row name based off this hard-coded name here, and then we were creating the active hitbox. But this is a pretty manual process, as I said, because we only are creating an active hitbox because we manually put these nodes in here. We could actually determine which type of hitbox to spawn based on the data in the data table row. So if we go into create hitbox from data table row, we can call the same function to get the data table row. So let's do get data table row. And we can pass in the name. And we know this is always going to be mutant hitbox data because we're in our mutant AnimBP. If you wanted, you could save out a variable and not have this as a hard-coded value, but this should never change in our Mutant AnimBP unless you have the ability to take someone else's moveset or something. You could have a variable for which data table you're currently copying and apply it that way. But that would be a very simple fix in the future if you wanted to update that. So now we know that whatever row name we pass in here, it's going to get that corresponding row. And then we have this out row, which is the structure of the data table row. So we can break this, or we can just split it. If you break it, it puts it into a different node here. If you right click on the out row on the get data table row, you can right click and split the struct pin. Whatever you want to do is fine for this. It's going to show you all of the parameters. You don't necessarily need all of them. In fact, you probably don't need most of them because we're just going to pass them directly into create active hitbox, for example. So I'm going to recombine struct pins so that we have the full structure here, but then I will do a break hitbox data so that I can access any specific fields that I might need. Then I'll go to my break hitbox data node, and you'll see in the details panel, I can choose which variables I want to see in here. There's also a button at the bottom to hide unconnected pins, which will disconnect any that are not in use. I do want to enable hitbox type, the very first one. This is incredibly useful because this can determine which function we call, whether we call create active, create proximity, create projectile, or create throw hitbox. If the row is found, that means we found a corresponding row name in here, which should pretty much never fail as we're already setting all the values in the array in Blueprint Initialize Animation. That's what we did over here. So all the names are going to be valid. We just have to make sure we pass it a valid index when we go to use this. Then we're going to spawn the hitbox of the corresponding type. So this is what I was talking about. We can actually perform a switch statement on this enum. So if the row is found, switch on ehitbox enum, and then call the corresponding function. So coming to our switch statement here, if it is of type proximity, we can call create proximity hitbox. Now this function only takes in the corresponding values that it needs from the hitbox data, whereas something like the strike hitbox takes in the entire structure. So strike is going to call create active hitbox. Throw is going to call create throw hitbox, and projectile is going to call create projectile hitbox. Now a couple things here. So first of all, we don't need to use hurtbox here. I did leave that as a type of hitbox in the enum if you choose to use it, but we're never going to be spawning it here in this manner. There is nothing wrong with that, but the way our hurtboxes are set up, we don't really plan on doing that, at least not at the current time. If you want to leave all these functions alone, where they only take in the parameters they need from the hitbox data, instead of passing it the entire structure like create active hitbox does, then you could add to break hitbox data, and say, for example, proximity hitbox requires the type, which we know to be proximity, but you could technically just pass it the type here. It requires the blocks done frames, which we could go to our hitbox data value here and go to blocks done frames, add it as a pin, and plug this in. And it requires the transform of the hitbox, which is under hitbox transform, which we could go and plug this in as well. For the create active hitbox, you could just plug in the out row. That is a hitbox data structure, and it passes everything into it. For create throw hitbox, we could manually go in and add all these. So again, you have your type, you have your damage, which we can enable here. We have our transform, our hit sound, our should cause daze, should cause crumple, should ignore hit stun decay, should ignore damage decay. And we have our create projectile hitbox, which is going to be the type. The projectile reference. Now, projectile reference does not come from the hitbox data. Projectiles are a little bit unique because they do spawn a separate entity that we keep track of. So in this case, we don't have this ready yet, but don't worry about that right now. Let's go to hitbox height. Damage, plug this in. Hit stun frames, which we don't have checked here, so add that. Pass this. Block stun frames. Pass this. Pushback distance. Pass this. Launch distance. Pass this. Transform. Hit sound. Should cause daze. Should cause crumple. Should cause air reset. should ignore hit stun decay, and should ignore damage decay. This is incredibly ugly. You could clean it up. If you want, you can leave it like this though, and you're good. You don't need to change these to an actual hitbox data structure and pass everything in. This will work. So keep in mind if you want to clean this up, or if you want to convert all of these functions to take in a hitbox data structure, and then you just break the data and use it here in the function like we did for create active hitbox. Either way is acceptable. So this is one possible option of how to handle this, but let's assume we want to handle it this way for now. But there's one other thing we need to account for before we start working with that, and that is our projectile reference. So for projectile hitboxes, we can still keep it in the same function, but we need to have an optional parameter of a projectile reference or a projectile to attach to. Otherwise, we're not going to be able to pass it into here. Now, in create projectile hitbox, this is of type default projectile BP. So coming into the function here, we can add another input parameter, and we can make it the same type, default projectile BP. This is our blueprint for our projectiles. And we're going to call this projectile parent. Projectile parent. So this will be the parent of the hitbox. And we could pass in this projectile parent to the projectile reference. And there you go. Now all of these will work as long as our row name is set correctly. So if we go to event graph and look at heavy charge active, we know this is representing the mutant hitbox data, and specifically heavy attack hitbox 2. This is index 6. However, data tables start at index 1, unlike arrays which start at index 0. So to access this from our row names array in our AnimBP, we would actually access index 5. 0, 1, 2, 3, 4, 5. So if we were to come to this event and go grab our hitbox names, get a copy. We don't need a reference in this case, but feel free to use one if you want. And we can get index 5. And instead of doing these two functions here, I can delete them, and instead I can call my create hitbox from data table row. And you'll see projectile parent here is empty, but data table row name is filled out. Now just to verify that this works without cleaning it up further, we can just go into practice mode, use that attack. My heavy attack I believe is Z, and it is, and I can see the hitbox spawn. It's that red hitbox right there. But it also does damage, and it should have the same data as what I would expect from the data table. So a good way to know that this worked is because we can look at our frame data for our character that was hit. The damage they received was 6, and the stun frames they received was 4. If we go to our hitbox data table, look at heavy attack hitbox 2. Now the damage is a ratio of 0 to 1, so it's a little bit harder to look at directly. We can do the math and make sure it's correct, but let's look at the block stun frames, because the second character was blocking, and they blocked the attack, so they received the block stun frames, which is 4. So this is just one example, but it does work. The rest should work as well. We can go through and verify, as I said, but I happen to know that this is accurate from doing tests before this. So now at this point, our function is already working. We could just convert all of these events over to use this new system, and we can also determine if we want to clean this up as is or change these to our hitbox data type. Now I'm just going to go through the animation blueprint and replace all instances of create active hitbox, create throw hitbox, and create proximity hitbox with our new system. I'm speeding this up, but basically I'm going to replace it with the same nodes we did in this episode. I'm just going to make sure I grab the right index from the data table. Remember, it is the number of the row that you see in the data table minus 1, since arrays start at index 0. I do have 2 exceptions to this. My events that support the 3D hitboxes. If you have been following the 3D fighter episodes, you'll see some of these. I am going to handle this, but again, I will handle that in the 3D fighter episode, so I'm going to leave it alone for now. And I also have this hitbox that we attach when we do something called our hurricane kick. And while it could work with a new setup, I'm going to address this and the projectiles in a different episode with the animation blueprint, because we can clean them all up together. Right now, they're pretty unique behavior for the hitbox, but they really don't need to be. But that's outside the bounds of today's episode. Additionally, I don't have proximity hitboxes for every single attack. I probably should, but I just haven't had the need yet. But I still want to transition all of them over to this system. So I'm just going to have all of my proximity hitboxes use the light attack HB1 hitbox. So they're all going to connect to the same function call using the same index. Additionally, the can move node that comes with the create proximity hitboxes can be removed here. This is handled elsewhere in the code now. Really leaving this here is just setting can move to be false twice, which doesn't make sense. So here are our proximity hitboxes. Here are our projectile hitboxes, and again, I'll cover these in a separate episode for the animation blueprint, and we can clean them up considerably. So just leave them alone for now unless you want to go through the process of converting them over. Once you've done all that, make sure you check all your hitboxes. They should all function exactly the same as they did, and mine are. If I missed any, I will convert them over in future episodes. But just make sure proximity, strike, throw, and projectile hitboxes still work. Nothing should have broken. It should just be a lot easier to work with now. Thank you so much for watching this episode on cleaning up your animation blueprint in your fighting game. If you enjoyed, please subscribe and consider joining the YouTube membership, Patreon, and Discord subscriptions to help benefit the channel. I'm incredibly grateful to all who have. Thank you guys so much. If you ran into any problems following this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description, and I would be happy to help you out. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.